Hello everyone. Let's start the day with some laughs, with some pain points, with some red flags, with some problems in the code that we need to detect. My name is Rentea. I've been coding. The introduction is, I'm Victor, and I'm drinking for the last 18 years. Coffee while coding. 10 years ago, thanks to a little project situation, I realized it's better to focus on people, and I started doing consultancy and training for companies throughout Europe. That's what I'm doing today, every day, meeting a lot of smart people from various companies. The topics are refactoring architecture, unit testing, Java frameworks, performance, and secure coding. This is what I do basically every day. I have a community. I love these things here on the blue so much that I created a community several years ago, which now is the largest community on the planet, focusing on refactoring architecture and testing. There will be a link at the end if you want to join. We meet online every month, just to have fun, to talk about different things. It will be a QR at the end if you want to join. And the past events are on my YouTube channel. And because life is complicated, a wife, 2 kids, and a cat. Especially the cat is the problem. So let's kick off with let's warm up a bit. How big should the method be? How many lines of code? 5? 0? No, come on, how many lines of code? Max? 6, 2, where am I? Just enough, that's the right answer. Come on, give me a number. 5, would you fail the pull request when you see 6 lines? 10, anyone more? No, really. The Bible says 20. I mean, after 20, it's a red flag. You could go 1 line, you could go 5 lines. But yeah, 20 could be enough. How deep should the method be? Top. How deep? 2. If you see 3 or more, it's already a red flag, right? How big should the file be? Oh, yeah. Depending on the language, 200 is Java if you're Kotlin. By the way, who's Java in the room? Java, oh my God. Oh my God, yeah, so 200 in Java for you guys. What do you feel about comments? Come on. This is interview questions. How do you feel about comments? Yes? No? The problem is they can cover for shit code, right? So they are good sometimes. They are good sometimes. Folks, yes, you can explain the why behind. I will be here 1 or 2 hours after the talk. You can talk with me. I will go with the mainstream things. It depends. Everything you're going to see, it depends. But I'm talking about the majority, the 80%, right? All right. What do you do when you see duplicated code? Copy, paste. Refactor! Yes, extract a method, call it both places, of course. How do we work with collections? Do you do a for? What should we use today instead of a for? Stream. All right. And what do you feel about setters? Setters. Boo. Data changes. Ew. Yeah? So yeah, we prefer immutable objects. And should I put a space between the parentheses and the var? Don't ask me this. I will auto-format when committing, right? What? All right, so you could say, yeah, that was obvious. That was warm-up, okay? So we're going to talk today about the code. All the slides are already online. Go to my website. There is, or to my social media. I published already on Twitter the link to the slides if you want to. There are many links that you might want to read in the slides. So, code smells. Code patterns that hurt you later. If it stinks, you have to change it, said my mother. So these are little red flags that you see in the code. For example, copy-paste programming. We need to extract stuff out, right? The principle that says this is dry, don't repeat yourself. The fun is the antonym. We enjoy typing. This is really... Anyway, dry, so you want not to repeat any serious logic, but then you can go too far with this. If you try to remove duplication between any piece of your logic, what's going to happen? What's going to happen? If you try to make a method to do many things, what's going to happen with the method? It's going to grow very complex, right? It's going to have look, this takes A, B, C, D, falls through -1 in the lambda. Yeah. Right? And then it uses 10 dependencies. Oh, and these guys extends. All of these are abuses just because we are keen of not repeating any line of logic. That's stupid. Going too far, again, can harm. Actually, worse if you do that. Right? So, and the worst that can ever happen is to have imagine two unrelated flows which are very similar in 10 lines of code. You look at the two unrelated use cases and you say, duplicated code, and you extract a method coupling two flows that should not change together, that will change independently. Do you see the legacy coming in? I have a legacy code. Rising, the rise of the empire. So only unify code that will change together. Don't start pushing, don't start extracting just because the code seems to be similar. Continue this quote. There are only two things hard in programming. Caching, validation, and naming things. Naming is so hard because, and not by one error, thank you. Caching is so hard because, caching. Yeah, caching is hard. Naming is so hard because if we can name the beast, you defeated the beast. Have you seen The Exorcism of Emily Rose? If you can name the beast, you defeated the beast. You understood what that does for you. That's called single responsibility. So bad names is the most prevalent, is the worst code smell really today. DR. What the heck is DR? Doctor. Exactly. Now it's days rented. Who knew? Lambda. You put a lambda and then you pull 20 lines of code. Hail for JavaScript. Right? Yeah, let's put everything inside. Why don't you extract it and put it in a method, right? Maybe just before that, if I'm talking to front end now, const. Const f equals lambda. And then you explain what you're doing in the lambda. Update place. This is a very technical name. Doesn't tell you why you're doing it, what is the purpose. It tells you that you're going to set some fields. Yay. But what is the function intent, right? Movie type price code. Oh, I love this. I love this. Pick one. How will your brain relate? What would you use when thinking about the code? Would you use price code or movie type? Yeah? So you're going to have a brain attack, a brain panic, a brain kernel panic. Don't use synonyms. Check customer that you find out it sets a field. It sets a field. Yeah. Did the name suggest that? Did the name tell you that? No. Would you expect compute price to cause an insert? God help us all, no. Right? That's misleading names. Technically, you are violating a principle called command query separation. You should not be changing stuff if your method claims it's returning stuff, basically. Right? So bad names is my favorite in Java. Hey, multi-bot supporter. Hello, entertainment provider view controller. What the heck is this? Spring? Sorry, what is this? So go for names that relate to the domain of your application and are powerful, easy to remember. That's not a multi-bot supporter. That's not an entertainment provider singleton. That's a TV. So the point is, powerful names allow your brain comfort to manipulate them in more creative ways, right? You will die if you read three words. Your brain is dead already, right? So good names are distilled just like tuica, like rakia. Multiple times you have to pass it through until it gets correct. Excellent. Good. Now, the next set of problems has to do with stuff that starts off small and innocent, and it turns into something humongous and absurd. Right? We discussed that the method should be less than 20 lines with a decent depth. But there are more subtle things going on, like a function doing both low-level date parsing formatting bullshit and high-level business rules. You don't want to mix both in the same method. Right? It's called separation by layer of slab or slap. You should slap the method. Separation by layer of abstraction principle. Right? Lambdas that are too long extract as a method, of course. And a class over 200 will kill our brains. So what we want to do is to split it either in master worker, like high-level policy, the facade pattern, and the domain service, or the thing that does the retail detail, or separate them in classes because they do different things in the end. And there is a very interesting thing from psychology going on here. It's called the rule of 7 plus minus 2. It's how many things a human brain can keep in working memory. You should not try to squeeze in someone's brain more than 5 bullets. Try with your wife, with your kid, with your boss. Try to enumerate 9 things and ask them to remember them. Tell me, what did I just said? They can't. Your human brain cannot do that. So you want to allow maximum 7 tiny ideas per method, or maybe max 7 methods per class. I heard someone saying that once, right? The magic number 7 is super important. The amount of content that the brain can digest and keep in hot memory is the number of CPU registers that your brain has. What? 7 variables per method. No, because with 7 variables, you're going to do much more than 7 things. Thank you for playing. Good, excellent. So split the method. The last one, too many parameters. You should ask if that function isn't doing too many things if it takes 7 parameters. But you might be lucky, you might actually be lucky and identify in that signature a new type that you did not see until now. You might be running into a thing called, I don't know, interval, start and end. You might group together in new objects that you can reuse afterwards, right? What should you take away from the previous slide? Whenever in doubt, extract a method. So when you have this feeling something is fishy, what's that smell? Alex was like, what's this? You're coding. If you have this feeling that something is fishy, start by extracting a method, right? And we just describe an idea in which you might find different unrelated pieces of logic that might actually move together through the code. Every time you find that thing, you find the int. The code smell is missing type. It had multiple other names like data clumps, missing abstraction. But the point is, group together the data that belongs together in new types, right? So make an interval class with start and end. Now, again, let's hail for the front end, for the dynamically typed languages in the room. PHP and JavaScript and TypeScript. Please raise your hand. PHP, JavaScript, TypeScript. Maybe even Python also. Few hands. But many of you are full stack. Right? Okay. Oops, what's this? I'm writing JavaScript. Look, ma. So you will be tempted to pass an array around, right? An array, a degenerate structure by just having some keys and some values in a dynamic language. That's a problem. It's called Armageddon. Actually, this is what ChatGPT suggests to call it. It's catchy. Armageddon. You pass arrays with no types bound to them. Create a freaking type, money with a mountain currency. Right? The other view, anyone Scala in Kotlin? Haskell? Scala, Kotlin, Haskell? Scala, Kotlin, Haskell. Hello? Scala, Kotlin, Haskell. Where are you guys? Just 3 of you. Huh? You raised 4 figure. In those modern functional languages, there is anyone Webflux, Monoflux. Few of you, you were lucky. No thanks, thank you, no, I will pass. Very good. There are some of you who might see a tuple 4, which just groups together some random data in a structure that doesn't mean anything. It's a tuple. I want to go to price product, right? So, discovering a new class allows you to use that class to pass it as a parameter and simplify signatures, allows you to destructure, to break down larger structures. When you see someone that has a start and an end, you can group them and say, you don't have start end, you have an interval. Right? You simplify the model very much. And if you upgrade that type from being just a structure to actually having behavior, you can put logic inside and constraint inside. So you could have interval dot intersects another interval. You see? This is object-oriented programming. Thank you. Or you could actually make the interval guard constraints. Few teams do that still. But it's interesting, like an upgrade, not just to type, but actually behavior. Okay. All right. Honorable mention. The honorable mention goes to util and helper classes. Where do you put some shared logic that you don't know where to put? So the first thing, the problem with the utils is they grow humongous. You should make orders. So at least collect selectively Romania, please. We are lost in Europe about selective collection of garbage. Please, the DB utils, date utils, string utils, right? I should tell you that if you take the step towards a more modern language like Kotlin or Scala, you will find that those wonderful languages have extension functions. You can add to the date type a new function. Can you imagine this? Or to the string. I have string dot a new function. Whoa, right? Welcome to 2000s. Right, but if you don't have extension functions, you are stuck with utils. You cannot add a function to string, right? Continuing the game with the object-oriented, Please imagine some piece of logic that operates heavily on the state of another object. There is logic over there, there is fields over there. Right? And that is envying, it's called feature envy. You have some logic, looking like, the data is there, why is it there? What should you do? You should bring the logic next to the data, says object-oriented programming. So don't start playing with the state of the player. To grab this logic, shovel it in a method inside the player object. Uncle Bob is gonna be proud of us. It's an object with behavior, and that makes your code simpler. It makes your code more easier to grasp for human. Player.advance, it's a story. Another pile of logic is method changing the state of the player. And this is related to another code smell, data classes. Who here uses Lombok? Lombok, yeah, what, half of Java, right? More than half. So do you do data, data? Data, it's like going back in C++ in type def struct. Data is like making fun of your objects. Why don't you make fields public, to be honest? What's wrong with that? Oh, it's not encapsulated. And data is. The point is, data, if you make your structures contain absolutely no logic but getters and setters, logic will have to accumulate somewhere. So please welcome the service. 500 lines. Why? Because the objects are just getters and setters. So the balance is somewhere in the middle. You want objects to help you with logic and constraints to simplify the core behavior. Right. That's old, Victor. We knew this. What's wrong with this code? Start here, return here, interval.start. Find by ID, return repo find by ID. Wonderful. Wonderful. You feel enlightened when you write code like this, right? This is bullshit. This is noise. This is boilerplate code. This is garbage code. It's, the name here is very, 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 very subtle. In direction with no abstraction. It means there is one more hop in the method chain, but without adding any simplification to your world, without actually helping you crystallize what's going on. It's just delegation forward. This is probably one of the most debatable, whether you want this or not. So I'm here afterwards, you can debate. Generally, that's stupid code. Increases the noise in the code. Sometimes we need it. That's all I'm gonna say. Oh yes, redeem coupon, long customer. And then the caller does redeem coupon, customer coupon. Do you feel it? Do you see it? It mixed the parameter order. Salute. It makes the parameter order. I swapped the parameter order, so what can I do? Any brutal idea? I want to come from you. Make a new class containing what? A single number? What the hell? Yeah. Let's see. This one. Long to the list of long. What do these mean? You're dead. You have to track down who put what in the map. You see? Or this tuple tree, long string, and this string you find in the specification that it can only take EMEA, North America, Latin America, and should only be one of these strings, says the law. This is called primitive obsession. What you can do is to create microtypes, little stupid classes that only wrap over those numbers, even an ID. I know it's absurd. You can say, what is this? Coupon ID, long ID, that's it, one field inside. It's a bit aggressive. And until Project Valhalla is over, is finished, it's going to eat a bit of memory. But the idea is you have types in your signature. No one can ever confound them. Make sense? You have customer ID, coupon ID. Okay. And this string over here, of course, it becomes an enum. Because only one of the values. No shit, let's make an enum to make the codes clear and safe. And now it's clear what this long means. You see? This, again, is a debate. Few teams do this. And it's usually useful for those IDs that are critical for your business. For example, IBAN. Satellite ID, order ID, things that you group, things that are fundamental identifiers in your system. Not for everything, of course. Okay. There is OOP twice in this slide. Yeah, functional programming. The rest of this discussion goes about functional programming. I rushed about those because those are old. But now we can use functional programming. Kung Fu. So let's first start by understanding, by sketching, how did functional programming change the way we work? In the trenches, in our day-to-day life, what difference did it make? Well, first of all, you know the quote, functions are first-class citizens? This lambda thingy is syntactic sugar that helps us pass behavior easier. I don't need to wrap an object like I did prior to Java 8, right? I don't need to do that. I can just pass an arrow, right? Of course, a bit duh. So that helps us in day-to-day life. And one more thing is critical, it's changed forever the way we work in Java, is the way we work with collections. Using streams, filter maps, you don't need anymore to change data. You need less mutation. You need less, there is less need for reassigning a field or variable. You can just compute and return. So it simplifies collection and it allows us to pass behavior in. That's why we care about functional programming in day-to-day life. However, the philosophy of functional programming is a bit different. How should the data be in a functional programming style? Immutable, thank you. How should functions be? Pure. And you put angels now, please. Pure. And what is a pure function, please? Doesn't change any state. That means no side effects. And one more. Everyone forgets the second rule. No matter the time, no matter any, given the same inputs, you will get the same output back. So you were right, the critical, the painful one is no side effects. This is the drama. But also, you should not be using random UUIDs and stuff, because it will make your function return a different thing the next time it's called. Good. So basically, functional programming is programming without side effects. This is the philosophy of functional programming. So when you play with streams, you need to keep this in mind. But let's talk more about immutable objects. So the problem with mutable data, objects with setters, you can imagine, is that if you pass them to very complex flows, at some point someone is going to change some data inside. And you won't be able to track who changed what. You won't know who changed what. Plus, moreover, if you play with multi-threaded code reactive kung fu, God help you all. So immutable objects are there for you, but they come with some problems. Now, I've seen a lot of pain in more than 130, I'm not sure if you realize 130 companies, what madness I was able to see in this life. And every time I meet a team using immutable objects plus Hibernate, I see pain. I see shit. Object relational mapper was not built with immutability in mind on reverse. No, object assumes you change objects that it has to flash to a database. Do not put your entities, Hibernate entities, immutable. Do not do that. Thank you. The next problem with immutable objects is memory burn. You can burn memory by allocating many objects. For example, I wish there were more Kotlin in the room, but still, this is, Kotlin is made 20 years after Java, fixing all the problems in the Java language. So if you do this in Kotlin, the list is immutable. But you know what the problem is? You fold, and this plus over here, what do you think will happen when you add an immutable list, an element? Create a new object. Oh my God, 400 megabytes of allocated RAM, for 5,000 elements, not 5 million, 5,000. This is killing spree. You are burning your garbage collector. You are destroying your performance. That being said, this is the only problem I ever. Anyway. Kotlin rocks. But this, you can abuse immutables, right? Like this. Okay. And there is one more point I want to make. You see, when you design your immutable objects, we often define them too large, with 20 fields. If you make an immutable object with 20 fields, God help you all when you try to instantiate it. So the next thing you're going to do builder. But wait, Victor, why is builder on the same slide with my mouse died. Why is this on the same slide with code smells? What happened? Are you suggesting it's a code smell? it can be. First of all, other languages don't need builders because they have named parameters. Folks, as we grow more experience, we start to be exposed to more languages than just Java. So you need to be prepared. Other languages don't need builders because they have that. Right? But then you, in Java, you use @builder with Lombok, and you have toBuilder. That's a problem. When you do toBuilder, it's like you come back from your immutable nice object to an object that you can freestyle change anything. The problem is, nothing tells in the code that A and B should change together. Your model, your code does not suggest that. You have to, so you can randomly change any field you want in there. That's a problem. So what am I suggesting? Meaningful names, handcrafted builders that explain that when you set a full name, you have to pass first and last. Or withers. Ever heard of withers before? Getters, setters, and withers. These are methods in the object which produce a modified copy with semantic reach, with full name first and last. You see where I'm going? This is interesting. So I'm combining modeling, more advanced, more fine-grained modeling with immutable objects. Or even better, I might decide that first name and last name should belong to a new object. Ladies and gentlemen, please welcome the full name. A new class. Builder might obscure this from you, right? So be careful with builder. That's the point here. Can you tell me why this code lies to us? This code lies to the reader. Why? It's not the average yet. It's the sum yet. Oh, shit. So you see, the code is lying to me. The variable average does not mean average at line 5. So what should I do? Change the debug message, sum equals. That works. But you know what I want to do? I create a new variable, right? To have variables mean a single thing. We have a sum at the beginning, and then we have an average computed out of the sum. Make sense? Right? Variables should not be reassigned. How can you enforce this in practice? Well, some people make all their variables final. Okay. It turns out that IntelliJ can actually automatically add the final modifier for you. Automatically, you don't do anything. You just format the code, boom, final everywhere. Read this Stack Overflow link on the slides that I posted on social. Others, much more maniacs, they use a compiler that can fail compilation if they see you reassigning a variable. This is hardcore stuff. Error-prone compiler by Google that fails compilation unless you put an annotation @var at line 1 there. What is this? Madness, madness. In the meantime, what do? Me, a simple man? I look for IntelliJ's warning. Do you see this? Master, 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 master. Reassign local variable. That underline 1 pixel solid light gray, that's what it means. This underline, you see it? So watch out for changing in variables. Oh, I'm going to skip this. Right. 4. What do you mean 4? Yeah, 4. What's wrong with 4? Well, 4 was famously included in the code smells chapter. That clock is 5 minutes behind. Why do you do this to me? 4 was included in the code smells chapter in 2019. It was labeled to be a code smell. Why? If it grows too big and does more than a single thing, or if you could rewrite it with a functional pipeline to solve your stuff in one line or in one expression. And in the back, someone is now relaxed because he's using while. Excellent. No, the loop is the problem when it grows complex. I beg you all, try to look at your loop and reason. Is this doing 3 unrelated things, adding to a list, computing a total, and then, of course, you start cutting it. Break. 3/4. But that leads you to another problem. This is an anti-pattern. This is an anti-pattern. You start with an empty collection and you start with a 4. Guess what happens inside? If there is an empty collection above, and then you do a loop, take a guess. What do you think is happening inside? You're going to change the list, right? You're going to add to the list. When I see just this thing, just this, for me, is a code smell. I don't even need to read into for. I know what's going to happen. You're going to mutate the list. How dare you? So, stream, right? So from one code smell to another. Accumulator loop is a new code smell on the market. If you start with a collection or with a number and then you jump in and you do some add or some, that's a mistake. You should reject the pull request. Okay. Oh, the guy wants to use stream. And he does stream filter, order is active. And then he's a graduate hire. Because he had enough, he does for each total plus schedule. I had enough today, it's good, yeah. But what's gonna happen in Java if you write code like this? It's hard to tell that immediately, but this code does not compile in Java. Because lambdas cannot change local variables on the stack frame for some concurrency, multi-threading kung fu logic reasons. So, what do? They turn the variable into an int array. Or they use atomic integer. We call this the Putin problem. So this is not fun. This is wrong. They stick with their mutability by moving stuff on the heap instead of the stack. This is wrong. But you know why this happened? Because IntelliJ suggested you do this for many months, many years. It took them 3 years to come up with the correct suggestion at Alt-Enter. The correct suggestion is avoid mutation using stream API. It took them too long to implement this quick fix. In the meantime, developers were putting code like this. When they noticed what happened, they implemented this auto fix, basically. So if you write code like this, IntelliJ is going to suggest replace it with this is the correct form. So what am I trying to say here? You see the for each in here? That for each should not do side effects. We call it mutant pipeline. You start with the pipeline, and it does data mutations, changes. Don't do that if you can avoid it. If you can avoid it, don't do it. So don't start putting in maps, incrementing an atomic integer, right? Or adding. Don't do that. If you can avoid it, do collect, do sum, do something to avoid, right? Quick parenthesis, there are valid reasons why you want to do side effects in here. At the moment you want to reach outside the system. In that case, so be it. But if you can avoid the side effects, don't do side effects in for each. At which point, the same guy in the back is relaxed because he's doing this. Or this. Peak, you know, peak? Yeah, I'm okay. I'm doing peak. It's not about me. No. Folks, side effects are bad. Try to avoid them. That's the functional programming ideology. That's the functional programming to reduce the risk in your code. Now, this was a misuse. Someone did not get the point. But let's see how we abuse functional programming. First of all, do any one of you believe that in your current code base, people played too much with functional programming principles, with ideas, with constructs? Yeah, I see some 10 hands in the air. So people can abuse functional programming kung fu. First of all, functional chainsaw, the famous. Look, ma, somebody stop me. Keep pouring, dot, 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 dot. This is killing. Remember the rule of 7 plus minus 2? What the hell is this? So the first thing you want to do is to identify little parts of this code and start explaining them with variables and methods. Make sense? Create variables, of course. I mean, duh. Of course, Victor. If you really want to go next level, you can embrace another principle from functional programming, which is that functions can be one expression. It's called expression functions. Kotlin, Scala, TypeScript can do this. You start a function and you say equals, the function definition, and after the equals, you continue with one single expression. How cool is that? In the meantime, Java is like, return. This is a good practice in functional programming, to have functions returning one single thing. Reduce rodeo. I hope for more front-end in the room, but this will hurt you once, I bet. Least reduce. Do you know the reduce operator? Excellent. Let's see how many things are happening on this line. Null safe accessor, null coalesces, a new instantiation, a greater than equal. Did you know that? Okay, of course, GTE. It's not GTA, it's GTE, yes? It's not A here, it's E. And then of course, a ternary operator. What do you think? I mean, of course. And at the end, the devil. What the heck is this? This is a copy-paste from it's safe because it's completely agnostic to. It's a copy-paste from some team I worked with recently, several weeks ago. What you need to do instead is to prep the collection, do a filter, do a map, kindly massage the idea, come up with the collection you want, and then reduce max by price. Done. You see what my point is? Very clear the intent of the code. In TypeScript, you can define a function just above you, right? But if you are in Java, do not use reduce ever. Do not use reduce. If you are, anyone in the room, you are one of the brightest minds in your company. You've seen stuff. If any one of you have ever seen a valid reason of using reduce in Java, please hunt me down afterwards. I beg you. I want to learn from you. There is one extreme case. I had heard some reasons, but tell me if that happens. Hunt me down. In the meantime, reactive programming. And this is a simple chain. In reactive programming, I won't go in here, but in reactive programming, this is the mandatory way to write code. By chaining ad infinitum your stuff in order to avoid forgetting to subscribe or resubscribe. This is the and now let's talk about clean code. What clean code, my friend? So me, as well as the community Java, eagerly waits for reactive programming to die, or to at least reduce the scope thanks to virtual threads in Java 21. This is fun. This is very fun. Play with me. This is fun. This is hardcore stuff. Long boring. And someone see, I'm going to use the mouse so everyone can look in their monitor. Long boring. Calling a process method. Actually, this is the old slide. Oh, yes, I've refactored the slide. What do you think? And this check, but no. Sorry. So the boring goes like this. Process of data, log info, save to DB, audit. Boring, simple, bank style. Good. Now, the process calls into this method here, we see, process. But this process throws an exception. And then the guy maybe reads some anarchic literature that says that in functional programming we shall not throw. Maybe he comes from Go, from Golang. Maybe he's under the influence of Haskell from his faculty and wants to prove the science to his colleagues. So what he does, he returns a try. He returns an object which captures the result and the possible error that could have occurred. And they return that to their callers. What would the caller do? Saying, a try coming back. Whoa, what is that? A try. Shit. What next? Well, you're going to force them to go change style because of that. You're going to force them to do, what the fuck? So you know what this brings back to me? Memories of the checked exceptions. You know checked exceptions in Java? I know it's the only language in the world that has checked exceptions. It's the only language doing this mistake in history. No other language has checked exceptions. We do. Don't use them! So, when you return a try, you are technically polluting the caller the same way you were polluting by returning a checked exception that they had to handle. Remember? I mean, we lived those days. You've seen, hey, this method throws exceptions. What will I do next? Shit, I don't know. Throw it further. Right? So, when you are presented with a try, you are forced into this madness over here. But let's be a bit empathetic. Let's be empathic with the guys. You know what really happens with the guys that do this? They are caught in transition. They come from a wonderful language, usually Scala, and they are forced into writing Java, which is made 20 years before Scala. And compared to Scala, it's shit. So what they do, feeling nostalgic, they come back to their habits in Scala. But you know, when you move to a new country, when they're speaking a different language, you have to change your habits. I'm talking now to those of you who try to immigrate. You're going to have to change your habits, right? So go Java style. Java style throws exceptions. Runtime, and let it fly. Let it fly. Let it fly. Until the exception handler. Okay. Time is kind of pressing, but I just want to mention this. you see, with functions, for function programming, you can take and you can return functions in and out. Although that's literally possible, please avoid doing this by all means. Human brain, when it sees you returning behavior, panics, says, you return what? Something which is going to be called. When? In what thread? In what transaction? How many times? These are some horror questions when reading this method, right? So try to avoid taking and returning behavior. Sometimes is necessary, but let it be. I want you to write an essay, a paper, to explain me why in the pull request comment. I had to use a function as a parameter because that heavy, okay? Bless you. That code. The easiest of them is the code which is grayed out in IntelliJ. Alt, enter, remove. Excellent. Yay. The nasty one is that if. No. Reflection, yeah. Correct. That code. That code. That code, which you think is impossible to happen. Would you delete the if? Oh my God. That will be the last thing I delete. Oh, damn. So this is a hard problem, very hard problem. How do you find code which is dead in your code? You can monitor API calls. Some people try to use profilers, all sorts of. But here's one. Please, first, I beg you, Git blame the code. Perhaps it's recent. If it's recent, call the guy. You're Victor. Is that still needed? No, thank you. Delete. And there is one more trick I want to share with you. This is really fun. Log warning. Delete this code if after September 2024 you don't see this log in the. That's smart. Not comments, log warn, because you're gonna look in the last 6 months log for this warning, and if you don't see it, kill. Not the comments. I need to search in the logs for this. Juniors are eager to write code. Seniors can't wait to delete it. Yeah. I need the bike. And here comes the bike. Yeah. You know where I'm going, right? Over-engineering. Hey, let's make a rocket. But they need a bike. It's below my competence. I need to take 2 functions as parameters. Simplicity is the ultimate sophistication, said Da Vinci. Keep things simple, right? Yes, good. What was made in '95 and fills the room today? Java. It has its own weaknesses. It's a wonderful language, and thanks to recent advancements, it's the best language to be in today, while playing in Kotlin for your pet project. But at work, you want Java. So, there are problems with Java, getters, setters. Lombok helped. Records helped more. Null, optional, yay. Other languages do it much more fun, but checked exceptions, die in hell. No default, no named parameters. The consequence, we have overloading in builders. This is a language weakness. No extension functions. The consequence, utils. Right? Collections that you can change. And they try to fix it. Unmodifiable list of Guava created immutable list. They try to fix it, but they struggle. Kotlin started, and Scala started with the right foot. Collections are bar default immutable. Right? So, these are the cosmos we've covered today. Bad names, long methods, large classes, too many parameters, a for which is too big. Missing a type, feature envy, logic away from data. Stupid code that delegates further. String, long int. What does that string mean? Accumulators, for that put stuff in a collection. Imperative function. We play with string, but then we do for each list add. Right? Like epic fail. Reduce rodeo, complex expression in the reduce, functional programming without stopping, like long chain, mutable data, temporary field, not everything really, and that code and over engineering. So, reading guide, it's all on the slides on the internet, but is this the end? I hope not. I hope you will join the community. Pick up the phone, scan the QR, be there. We're meeting each month to talk about stuff. There is over 100 people from throughout the world, live, talking to each other. There are hundreds of comments in the chat while we discuss the topic. It's insane what happens in there. There are CTOs, people with 35 years of experience that join to share and to ask and to debate. Very fun. It's on YouTube and also on Zoom. It's more fun in Zoom. This is where the heat is. Join the community, completely free. And I was Victor Rentea, and I thank you all and wish you a great second day at Vox Days Conference! Woo!